whenever limits are studied, we do some standard forms of limits, and one such form is limit x tends to 0 sin x over x is equal to 1. And based on this standard form, there is a problem, a homework problem, which is saying evaluate limit x tends to 0 3 times sine of 4x over sine of 3x. Now we know vaguely that this form certainly uses this standard limit. I am going to change the ink here. This limit, and we would try to find out the easiest way to convert this to look like this. So we look at the given fact, which is x tends to 0. So we say that given x tends to 0, this implies that 3x tends to 0. Also 4x tends to 0. And obviously, because I am seeing 4x here and 3x here, so I am interested in these limits. So we can convert this limit by saying limit 3x tends to 0, 4x also tends to 0. You can write here whatever quantities that tend to 0 related to this limit, as long as this basic assumption is not neglected. So we will write 3 sine of 4x over 4x divided by sine of 3x over 3x. Now at least I am making these look like this, but certainly I change the things, so I am going to make it times 4x times 3x, so that I can cancel 4x with 4x and 3x with 3x without changing anything which was given to me in the beginning. And you must also note that to be mathematically accurate, you cannot divide by 4x and multiply by 4x unless you are very sure that 4x is not 0. And we can say that 4x tends to 0. This implies that 4x is not equal to 0. The same logic, 3x tends to 0, implies that 3x is not equal to 0. This is very fine but required observation, so that you are not dividing numerator by 0. Now we can say that limit 3x, maybe let's take 4x first, 4x tends to 0, 3 times sine of 4x over 4x. I am carrying this limit and associating with the numerator, and I wrote here multiplication sign like that, which can confuse with x, so I am changing it back to a dot. So I am moving limit 4x with the numerator. Similarly, I am moving limit 3x tends to 0 with the denominator, where I write sine 3x over 3x and 3x here. Certainly this comes from algebra of limits, and I am going to write that here. If you recall, if limit x tends to a, fx over gx is given, then we can write this very easily as limit fx x tends to a over limit x tends to a g of x or gx. You can move limit to the numerator and denominator, or whichever quantity where the limit is concerned in that expression. So we have now and I'm not, because of lack of space, I'm simply going to say that limit 4x tends to 0 sin 4x over x, this tends to 1. Similarly, this tends to 1. So what you are left with is 3 4x over 3x, which is equal to x. X will cancel since x is not 0. 3 will cancel, and so 4. So that's the answer.